when it comes to binding energy calculations, PBSA has a good balance between performance and precision. Several tools have been developed over the years to perform PBSA calculations which are compatible with GROMACS trajectory. Among such tools, GMX PBSA is one of the most advanced, and it is currently under development. There are several ways to install GMX PBSA2, and we are gonna use Mamba resolver, which is an alternative to standard conda resolver, to create a virtual environment and to install all the necessary dependencies for GMX PBSA. You can use conda to activate a new environment even though it was created using Mamba. We also need to install Python bindings for Qt, which are used by graphical user interface program which comes in pair with GMX PBSA tool to analyze the results of PBSA calculations. Now it is time to install GMX PBSA. Make sure that you are using Python and pip from your new environment and not your local Python and pip. Otherwise there is no point in creating virtual environment in the first place. All dependencies must also be from your conda environment. Finally, let's check the version of installed GMX PBSA2. Before running GMX PBSA, you must prepare all the required files. It is also highly advisable that you create a separate folder to run such calculations. You must preprocess your trajectory to leave only those index groups which you want to analyze. Also, you can remove all solvent molecules from your system. You will also need portable binary input file which you have used for running a simulation, all the input files with topological parameters of your system, file with index groups, and the PBSA input file with parameters of your future calculations. In the PBSA input file, you can specify both general variables like the path to your GMX binary file which you use to run GROMACS programs, the number of frames to analyze, where to start your analysis in your trajectories, and there are also physical variables which impact PBSA calculations, and some of them are actually very important and can lead to large differences in the results of your calculations, such as, for instance, internal dielectric constant value. Finally, to run GMX PBSA, after you have prepared all the required data, you can use this command, which will also be in the description to this video. GMX PBSA supports multi-processing, so you can parallelize your calculations. Depending on your system, you can specify different number of jobs to perform. In parallel, in my case, I use 4 separate processes to perform calculations. GMX GMX MMPBSA supports modern force fields such as Amber, Charm, and OPLS. In my case, I use Charm 36 force field. If you use Charm 36 force field like I do, you also need to provide copy of the force field folder with all the parameters in your folder which you created for GMX MMPBSA calculations. You can run GMX MMPBSA tool to calculate energy of interactions between the different molecules and for various biological systems. And in my case, I calculate energy of interaction between two proteins forming a dimer. What makes this tool really useful is that it is compatible with your trajectory, so you don't need to actually perform a separate simulation specific for some type of energy calculations, like most of the methods for energy calculations require. So you can use the derivation of your final trajectory in MMPBSA calculations, and you can also analyze your trajectory with other different tools which you may want to do. The length of calculation depends on the size of your complex and the number of frames which you analyze. At first stage it calculates the energy of complex, after that it calculates energy of your receptor, and after that it calculates energy of your ligand. It can also perform additional calculations to determine how entropy impacts the energy of binding. After the calculations, GMX MMPBSA tool can automatically run a separate program with graphical user interface where you can plot the resulting energy of binding as function of time, plus you can plot other data related to the calculation. Now that the calculations are finished, let's check the output files. Most of the new files in the folder were generated at the preparation stage before calculations. GMX MMPBSA output is stored in 5 files, including log, two files with energy of binding as a function of time in different formats. And two files with the results of energy decomposition. Energy decomposition is an optional feature which allows you to determine how different residues impacted the total energy of your complex. Thank you for your time and let me know if you had any troubles.